How's it going, everyone? Welcome, Elvira Gonzalez. That's right, Aboteya. That means is here I am in Russia. You might wonder what the French toast wrong with you? I'm actually at least learning the basics, salutes in Russian. Uh, right now because I'm living here in Argentina, and there is a lot of Russians in my neighborhoods. Russian, Switzerland, Swiss, couple from Netherlands. I don't know how do you say that on that. Um, U.S. folks as well, Argentinian, Paraguayan, Peruvian, Bolivian, a lot of Venezuelan, like I am. So, but in any case, a botella. Here I am, okay? Zarova, which means is what's up. I really love that. That's kind of interesting to know about it. So, in today's video, I'm going to explore about is the side effect section from the additional tools that we have now in the language, right? In React framework, right? As a way to solve a specific problems, not relevant to how do we now define our UI using React and how React does that behind the scenes, but also is how do you now handle when you need to synchronize your particular state, how you do that, and where that source of truth is matters. So whether it's you are now capturing global events or reading and writing local storage, or fetching some data where now the source of data live on the server, and so fetch now data from it. Sorry. In how do you synchronize with timers as well, right? So all of this little nuance here is that the TLDR is the source of truth is the main concept here. And where the source of truth you want to synchronize or you want to get data from it, that is the problem that this specific custom hook known as useEffect solve. All right. Why? Because the TLDR is that as you write UI interface, so most of the time you need to make that specific UI to synchronize with external system, right? So whether it is, as I mentioned before, is synchronizing or subscribing to global events, okay? Whether it is provided by window, like window resides or mouse move, or even interacting now with the observer API. This is one of the most challenging sections because at the end of the day, this is what our UIs are valuable. At the end of the day, the ability to now is based on a source of truth that might live on the client, responding to global events or reading and writing global variables or global data from local store, or interacting now with the timers provided by the web API, right? And also is interacting is with other web APIs like the interceptor observer or the navigator. And I want to bring this up here a little bit because this is what is relevant here, right? So this is the web APIs, okay? So this intersection observation API, right? So this now allows us to synchronize with this API. You might wonder why this is useful or important. Well, anytime that you want to detect if the viewport now has certain threshold, all right, and now the element is part of the viewport, you want to show something, right? And I really, that's very, very interesting API, so we don't have to rewrite that for our own purposes. Okay. Uh, Another interesting is the navigation API and network API. So, for example, window.location, which allow you to now is redirect in this client-side navigation application, right? So the navigation API provides the ability to innate, intercept, and manage browser's navigation actions. It can also examine an application history entries, and this is a successor of the previous WebFlow features such as History API and Window Location, right? So the History API is, well, this specific API that allows you to have access to this, right? Through the history global object. It exposes useful methods and property that lets you navigate back and forth through the user history and manipulate the content of the history stack, right? So again, you can is move forward and backward for this case to manipulate is that particular state, or using is the window.location, which say, hey, I'm going to, this is the current location of the document. In this location, which is now something, for example, like this, right? And if you inspect here a little bit, the location, which is the location, I think is, you can access via the location or say window. I prefer to be explicit about it because what I'm saying here is that, hey, on this tab, I want to have access to this web API, like location. And here is gonna tell you is this kind of things. Hey, this is the location. I do have all of this, right? You can also is now replace this, right? So for example, if you say something like, hey, window dot location sorry, here, window dot location here, it'll be now https google.com, right? Which is this, and now is the browser that when that tab detect that value change, automatically change. Holy moly, that's right. Okay. You can also modify the location of using assigned and replace. So you can do something like this: window dot location dot assign, right? And here I'm assuming that I'm gonna pass is the new URL. I do prefer to do this, right? More like to follow a convention, right? Any navigator. Yeah, I prefer to go with the assign and the replace, right? Which is equivalent to assign to it is href property here, right? Again, for legacy purpose, they don't change that, but I do prefer that for new application, starting to use this assign and replace, right? So, but in any case, so here, yeah, here we are, right? So anytime that we need to interact with this, okay, particularly is which solves their shortcoming and is specifically aimed at needs of the single page application navigation, right? So now you have is this navigation interface, right? You can access through the navigation, and this is interesting because it's something that is fairly new, right? Fairly new. Fairly new. fairly new, right? Mm-hmm. Interesting. So now you can. Oh, okay. Mm-hmm. Okay. All right. Mm-hmm. So this is the entry point for the navigation API. Okay. And this navigation API, right? In our expose is this navigation API live demo. You have subpage, back to the index page, error console. What the French toast? What the hell? Navigation API. What? Okay. So if sample code. All right. Even the sample code doesn't work as intended. API live demo. I'm an index.html. I contain a normal link to subpage.html. All right. This link works without JavaScript and it all for browsers. Console, history back, location reload. If you hit here, this is location reload. Go to subpage in 2 seconds. So 2 seconds, it now redirect to that. So if I go to back to the index.html, it's now throwing me this error console. Please don't leave this page. Add an artificial 2-second delay on that. Okay. But again, it says, hey, I cannot read that. So it can. Again, this is okay. This is a read-only property, by the way. Okay. Okay, that's interesting. Okay, that's a read-only property for that. So in any case, right? I mentioned is this. So navigate, reload, back and forward, traverse. So I navigate is this because when you are now developing your UI, and somehow you need to add some business logic, and this needs to synchronize with external systems, right? Like navigation APIs or network information API, you know. Performance is another one, but I think with performance you can just access through the API, whether it's the interface or the property window performance, right? This is how you can access to this, and that is going to expose now certain read-only object containing latency related performance information, a non-standard extension in time origins. Again, I mentioned just the most common APIs that the web provide. So one of them is picturing in picture, right? So sometimes this is what you want to do, and even though it's a limited availability, so all right, pointer events, right? So global events, right? And they call this now pointer API, pointer log, power API. I think this is something quite new with the dialog, right? So you can actually do this, and the element will now show off on top of that. But you get the idea. Resize observer API. Screen orientation, screen wake lock, selection API, sensor API, Digi, storage API, which is to access the local storage, right? Whether it's you do that via the index, okay, to access the indexes DB or catch API data, right? Or even the web storage. There is also known as local storage. Storage access API, stream API, but you get the idea, right? URL API patterns, vibration API, crypto API. Again, there is a ton of them that are still not that applicable right now. The HTML DOM API, the drag and drop API, HTML sanitizer API, history API, and Houdini's API, device memory API, and device orientation event. Also the Canvas API. Hey, I do want to have to access and run this. So, but in any case, right? In any case, I just mentioned is the most common ones. All right. When you want to sync to, when you want your UI, when you want the state of your, when you want the UI React state synchronized with any other external system, or when the source of truth live outside of the React and you want to sync with it, right? This is what the useEffect allows to do. So after I went through several of this exercise, so first understand how now we can use the useEffect, especially to track when the state changed, and these state changes are now triggered by a particular hook that React knows what to do behind the scenes, known as the core loop. So then I also look at what happened when you don't define is the when I don't define is the array of dependency, right? Or and then I try to use those. It turns out that you can access to this particularly reactive or this state, and there is a difference between the state and reactive values, right? But in any case, you can access to this state because what this state is doing is recreating a new state or a new snapshot, a new version of that UI on every time that that state changes. This is something that is managed internally by React, and because in our useEffect we want to deal with, okay, what we want is to now somehow access to this snapshot. We now need to notify to the hook that this is the state that I want you to keep track of if you need to, right? So this is where this is the reason why you get this sometimes linting errors, right? Or effect linked rules. You can skip that, but before doing that, understand that you might have some problems. But now I see what this React state and the useEffect is doing, why they need to pass on that. Remember, the user state are there for remembering piece of information. And anytime that you update that state, the setter, it will recreate now the new snapshot of that, the new state with this updated piece of information. And if you trigger that again, you get a new snapshot and a new snapshot and a new snapshot. So this hook, if you want to have access to that particular state, you need to pass to the array of dependencies. Okay? If you don't do that, right, which is what happened when you now use this hook on mount, by default is going to trigger this hook right after the renderings. So this will trigger now on every render. So in other words, if I don't pass any variable here like this, right, and I try to resize this, you will see that how many times these things resize, even though that is so, you know, let me don't do that. Look at this. So the UI actually now what it's doing here is on any time that you are getting into this, you create all of this, right? So when I resize that, it create now all of this, all of this event, aka is now adding, or it's like stacking like hotcakes, all of this events handlers, right? But you don't want to do that. What you do, what you want to do is only subscribe this once. So for example, in our case, but again, it's still running multiple times, right? So how can I now prevent for that to happen? Okay, I only want to subscribe this once. So, or I can now is keep track of that piece of information, and only when that change now apply this. But unfortunately, here is going to trigger that on every render, and this might be something that you want. You might say, hey, I do want to now add this event handler here on any rendering. Unfortunately, this is what it's doing. So also you can look at this, but here is going to, you can say, hey, useEffect, right? This will only get run once, so no matter how many times that we call this, so we are only subscribing to this only once, right? Here it doesn't show that. That's interesting. Okay. But again, it's going to register only once, which is what we want. All right. But sometimes, okay, I also look at a couple exercises that was very quite interesting in terms of understand how you can now synchronize with a particular piece of state, or to and log that piece of information. How you can now is modify is, or to synchronize is the current tab with the external, this current tab here, with a particularly internal piece of information in React, again using the useEffect, and some more advanced exercise here, like, hey, I do want to subscribe only one event on mouse move, or when resize, or with the intersection of server API. That is fantastic, fucked up. Absolutely, man, absolutely. Absolutely. So, right? So then sometimes we need to is subscribe from that global event, right? Or somehow needs to, well, remove that. So it turns out that to do this, a lot of the time, okay. So to do this, right? Okay. Yeah. So to do this, to desubscribe or to now run this particular functions when the component is mounted, this is now where the cleanup kicks in, right? And the cleanup function is now a function that is going to run when these components are mounted. And there is a particular workflow on that. So when the component mounts, it runs the render and then the useEffect, right? So when the components re-renders, it triggers now the render, and then the cleanup function, which makes a lot of sense of the use effect, and then the use effect, right? And once the component it's deleted, now it's going to run is the cleanup function, and it makes quite a little bit of sense, and also is something very interesting because if you look at this, right? If you look at this, so what I'm doing here is that anytime that I resize here, wait, what the French says? Oh, you get it. I do one is two is first synchronize this, right? Right. And then I want to deregister this. So how do I deregister? It's like, hey, once you unmount this component, I want to remove the event listener, right? I want to remove the event listener. Here is going to trigger a lot of the time, but when I now remove that React instance, which is this instance is created on renders, not when not on your React components, not on the HTML elements. All right. So like this, say, hey, remove event listener on event target, 2 arguments required, but only one. Oh, there you got it. Okay. So yeah, and here we are, right? So now it won't trigger anything, right? Oh, that's interesting. That's interesting. Why are you still triggering that? You shouldn't do that. That's for sure. That's interesting. Yep, that's interesting. You shouldn't do that. And it's doing. All right. That's right. If I toggle up. Exactly. So now it works. All right. So now it works as expected. Good. So you might wonder, it's like, hey, this is interesting because I'm passing now a function the first time, and the second time now I am returning is a function. And this is when the function light or the functional programming kicks in to actually make sense of what this thing is doing, and therefore you're going to see the value and the again, all of this is because this is part of the natural evolution to be a competent JavaScript developers here, right? So that we need to also is understand not only how the basic stuff or the 3 pillars of JavaScript, which is the type system, the scope, and the objects, all right? But also you need to look at what are the things that are relevant in the industry. So like object-oriented programming and the functional programming. So it makes a ton of sense here to actually starting to digging in the functional paradigm, functional programming, something that go beyond of today's topics. But the TLDR of this is this. This is a particularly hooks that allows to hook in to React state or to React, and it's going to trigger now right after every render, and this is the function that is going to run. So this step allows us to this step allows to is once that render happens, synchronize with external system or to trigger some arbitrary JavaScript code here, right? And when that component is unmounted or when that instance is cleared out from the DOM, well, now it's going to run the cleanup function, right? So that makes a lot of sense here in terms of understanding is what is the thinking behind this, right? So what was the thing that the JavaScript developers and at Facebook they were behind, right? What are the idea and the problems here? So now I understand is this particular problem, and also is with digital clock. This is quite interesting. Why is this? Because now what you're saying is, hey, I do want is to now run this piece of code right after every render, which allow me to is after 1 second run this effect, or in this case update this particular state like this, okay? And that is pretty interesting. And that is pretty interesting here, because you can set now the date, you're gonna get the new date after that, and when these components are mounted, I want to just get rid of that instance, right? I want to clear up the memory here, which is get rid of that memory, right? And it's not counting. So this is how you can create. This is, oh my, this is the basic example here. Build me is a counter here, a timer. Build me is a clock, bro. Build me is a clock, right? Build me here a clock component, right? So when I click here, right, when I show this component, I do want is to render if this is on and on. So when this component is enabled here, right, so you want is to show me something. So because now I am in the React land, I do want to keep track of that particular state, piece of information, right? In this case, I'm going to create now a new date, right? A new date here, okay? And that is what I'm going to reference as the time and set time, right? Here, and then, okay, now, once this component is mounted, so not only that I want to render time like this, but I need to access to the React.useState like this, and of course, so this is what I need to is to local string. Okay, so I do now get this treatment here. So that's great. So so this is what happened on every render. So what happened on every render, I'm gonna get that, right? But I do not want to click on this over and over and over, because it's quite annoying, as you can see, right? So what I do want is to update that on every second, aka I want to schedule a task after the rendering happens. How to do that? Locally for us now, the React team say, hey, this is a particularly hook for that specific task, where you can pass as a function that is gonna be rendered initially, right? You can also define when you want to this task to run, and I want to only run once. And here I do want is to now synchronize with an external system. In this case, is the timer. Set timeout here. Set timeout, and I want to pass now here is a JavaScript function here, and update my state in React. This piece of information. Set time here. We say, hey, new date here, right? And I want to repeat this after every second, right? So I do want is to now do this. No, it's the set timeout. It's set interval. That's right. Set interval. That's right. That's right. Right. So I want to trigger this after 1 second, and then there's another one, and this is the new state, and this is the new state. This is the new state. This is the new date, and the new date, and the new date, and so on and so forth. You get the idea, right? But I do want is to now when I hide this, I want to get rid of that instance, right? And then show this again. So in order to do that, right, in order to clear to desynchronize with this system, we need to now run is, or we need to return is now a function that is gonna be scheduled right after this component is unmounted or after new re-render or after every re-render, okay? Where here is when you're going to define is this. Hey, but I want to clear the interval, right? Clear interval. But I don't have any reference to this. This is why I do need to create is some identifier with a let in this case. I prefer to go with cons, right? Some identifier because this is unique, okay, called timeout, and then do pass down here as it is. So now I'm sure that this won't be triggered after every render. How you can make sure of that? Glad you asked. Because here you can say, hey, this is the useEffect. All right. I just want to run the useEffect once when this component is mounted. That's right. So I just want to run is this when this component is mounted, right? But I do want to see if this piece of code actually gets triggered here, right? The timer. So you're gonna see timer is running, right? But after I click that, so timer is not running. So we get rid of that properly. So that function that we schedule through the via the timers is no longer there. And now we did this. So this is the whole idea and the whole premise around this, right? And I do think that's very, very interesting to know about this. So there is now, when the user ticks the checkbox, it should become reticle automatically after a half second, right? So you can set on, and then it's going to tickle to that, right? If the user clicks in a bunch of time in a rapid succession, the machine should wait a full 500 milliseconds from the final click before ticking itself back on, right? So in other words, it's quite of the same. You say, hey, React.useEffect here, all right? React.useEffect here. I want is to run is when this change, when this particular state change, right? And if this is true, then I want to is now synchronize to this. So I want to trigger now. So in other words, say set timeout, right? After what 500 milliseconds is this one. I want to trigger is this function. So that is this one. I want to set now the is on, right, to off, to false. Set is on, and I can say is to false, right? Pretty simple, right? Pretty simple. So what it's gonna do here is when I click here, the event trigger and a state update is going to call the components, render this or recreate the HTML with now this UI state updated, which is now toggle, and then kick off the useEffect, which is going to ask what is the value of this on state, which is true, and then now run a 5 millisecond timeout to set that to false. And this is quite annoying. If the user clicks it a bunch of times in a rapid succession, the machine should wait a full 500 milliseconds from the final click before tickling it itself. Oh, it's because I untickled that, right? Let's build something similar. We'll create a checkbox that automatically tick itself whenever it's unticked. It should become reticle automatically after a half a second. Oh, okay. It becomes. Wait, what? The French stuff? Okay, I must always set that to true. Okay, is that I must always set that to true. Oh, if this is false, set that to true. Exactly. Exactly. So what it's doing, no matter how fast is this state are changing and schedule that task, changing and schedule that task, changing and schedule that task, changing and schedule that task. Okay. Early returns allow us to emphasize an effect's primary purpose. We can clear away the conditions so that we don't obfuscate the primary purpose of this. So for example, like this, early return. And this is a particularly pattern here. This pattern is useful for all functions, not just React effect. And when we use it consistently, it makes it much easier for us to quickly understand what a function is doing. It is especially beneficial for more complex functions with multiple conditions. As another example, with which of these two functions is easier for you to understand? Okay. So always return is an early error. Exactly. It's an early error. It's an early error. The primary purpose of the function is to log the user in. In option 1, the primary purpose is buried in the middle of the function, nested within two if else block here. Like this. Exactly. Nested into if else block here. And that's not what we want, by the way. As I say, this is a subjective preference, but this is one of my favorite patterns. When followed consistently, early return make it much easier to understand how complex code is structured, in my opinion. That's interesting because now, since we talk about is stale, or we talk about now how this use effect is keep track of this particular state or this dependency, uh, the reactive dependencies. Okay, there is so my question is that how these things work. All right, how is that React now actually keep track of that state change, and why this is important? State values, stale values. When I first started using computers in the late 90s, I used two different media players. For live streaming, I had Real Player. Holy fuck, I'm old. Oh my god. Oh yeah. Yeah. For live streaming, I had Real Players, right? Real Players Welcome, like this. So Real Players Welcome. Real Player. I also remember that. Holy man. Excite. Holy man. Real Player was okay, but it didn't really was. It didn't really have any personality. To my teenage self, there was a much cooler option available. Winamp. Yep, I remember this S, bro. I definitely remember. Oh, like fuck. Winamp, bro. Aggregates the complete user need for their auto experience and offer features that help create a personal experience. Legacy player, bro. Legacy player developers. Yeah, what? You want me to download it? Oh, this is an executable? No, fuck. No, I won't download. Oh, okay. Learn more about the music industry. Winamp for creators. Okay, Winamp for creators. It is all in one platform that empower music creators by bringing together all the essential services they need to monetize their music. Winamp for creators. Okay. Winamp, bro. Holy man. Yeah, that's right. Mm-hmm. 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 Early in this model, we built a simple media player, and I think we should update it to include the spacebar shortcut. The space bar key will play or pause the current selected song. Early in this model, we built a simple media player, and I think we should update it to include the spacebar shortcut. Of course. Challenge accepted, bitch. If you are like, I encourage you to spend a couple minutes attempting this problem, but I warn you, it is surprisingly tricky. Okay. Okay. So if I want to use now this, okay. So somehow I need to is listen for this event, okay. Um, Global event. So I listen to that event, right? And not only that, not only that I listen to that event, okay, which is something that we can use. So listen to that event, uh, and then somehow get the reference of our UI. Okay, so get the reference, get the audio reference, and the button reference. Okay, it's like to get the audio reference and also get the button reference as an state here, and then I need to update that, right? So here's here three things that I need to do, right? On the React.useEffect, useEffect. Okay, so I do want this to run only once, right? There is no React here. What React useEffect here? Unexpected token. Oh, that's right. It's this one. Okay, so here's the three things. So first, I need to listen for a global event, global space key event. So once I listen to that, I need to access to a button element and audio element, trigger trigger audio or yeah, trigger audio or flipping between play and pause audio element, okay, based on its playing state, this piece of information. And once that piece of information is done, so I need to update the UI, right? Which is flipping the bottom element from play to pause based on its playing here. So because now I do have synchronize is the audio, or I do have it synchronize that. So what I can do is listen for these global events. So how can I listen to a specific key events, key event space bar, right? Keyword event, exactly. Keyword event. My question is, can I listen for that event here? Keyword event here. Event type is key down, key press, and key up. Key down, right? So is this particularly on key down, so I can listen for that. Then I do want to have access, right, to this particular event, which is the key. So in other words, let's go here and say, hey, window, in this tab I want to add an event listener that will be triggered on key event, on key down, exactly, key down, right? So key down that I'm going to now run is handle handle spacebar, handle spacebar, right? This is now a function that I'm defining here. So function here is handle spacebar. I'm gonna receive the event. I want to identify the specific key of that event, right? Okay. Oh, it's looking for the data? Exactly. Is the key down? The key down? Event key down? Press, and it's this one. Okay, this is the E key. So if the E key is now an space, right? So if the key down, so if the key is now equal to an space like this, all right, then I want to do this, right? So if this is so if this is now a key and that is an empty space, so now one is to is flip here this state, right? So I want to flip the state here. Set is playing is playing. We can do this, right? But also do want to pick the reference, and that is the audio dot ref. But this ref here, okay, is also kind of tricky here, because here we need is to verify if that is playing, right? If it's playing is true, right? So let me is now that reference audio ref exactly. So if it's not playing, let me set that audio ref to play, right? And now update that particular state, okay, which is to is playing. So if this is false, right, so if playing is false, then I want to say is playing to true. However, if it's not, all right, then what I want to do is to do this, right? Take the audio ref and pause that, right? and set the is playing to false, right? So of course it's going to complain about it because it say, hey, you are now accessing to a state here that I need to keep track of. Okay, and I say, okay, no problem. Window event listener, Jesus, is this, right? So not only that, so once this is done, okay, when you unmount this component, I do want is to now is desubscribe this, which is remove event listener, like this. So now if I hit here, it triggers that, and audio say audio ref play is not a function. Oh, because it's storing that object here. That's right. It's storing that object here, and now it'll work. It's not a function. What about now? Holy moly, bro. It was quite straightforward. It was simple. And I think that the interesting part of this is that with this is why the pseudocode, this is why the systematic thinking is quite useful, bro. Absolutely. This systematic thinking is tremendous, bro. Tremendous. Tremendous, my friend. Powerful, bro. Mm-hmm. Mm-hmm. Oh. Holy moly, bro. That is mind bending, bro. And this systematic thinking is crucial, bro. This is what you need to first understand the problem to actually do something here. Okay. That is mind bending stuff. Exactly. Is playing as a dependency. Is going to now on every render, every time the state change, is going to clean up and so on. So solving using a callback function. And the other is solving using a callback function. And the event bubbling. Event code space. Event code space. Event code space.
So in terms of our React code, the effects, the state, everything we've been talking about in this module, I am perfectly happy with our solution, but there is an unrelated, but nevertheless quite annoying issue with the way things work right now, and I wanted to mention it because I know some of you will have stumbled on this and wondered if it was a mistake you were making or why it's not something I covered. And the problem is if
So whether it's using this, so this works, right? But the other is setting is playing. Exactly, setting is playing. So if not playing, right? If it's not playing, so take the current playing state, right? And now flip it. Return the current playing state, right? And otherwise, you don't need this. Exactly, but you're not holding any reference here.
I focus the play button and I press the spacebar key, this happens. The song starts and then almost immediately stops, and we're left with the briefest hint of the music that should be playing. The reason this happens is that button tags
Okay. Holy moly. Okay, you use now two synchronization states for each one of them. Okay. Okay, so this is just to flip the That's interesting because now you're thinking in terms of React. Okay, so you're thinking in terms of React. This effect is just for do one thing, and that is flipping from one another. Okay, and then the other effect, right, is for actually synchronize. Okay. 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 And the other is to actually grab that instant. That is the audio. Ref dot current dot play right? Or otherwise, it's just pause this. No, but this is handle is like handle spacebar or play play audio on a spacebar, handle play audio on a spacebar, and handle flipping state, flipping play pause spacebar. But it detects that. Okay. Except this logic is not valid here. Like this. But it doesn't now trigger that. I'll be right back. And we're back. Okay, so look at this. So if this is not playing, so if, in other words, because now we are, this is one of the things that can be quite tricky to spot on, right? And this is very specific to the use effect, all right? Because of the logic here. The use effect logic is what can be quite sometimes convoluted to try to spot on, but it's because at the end of the day, trying to synchronize a source of truth, whatever it is, on the client or on the server, with your React application, or in other words, with your JavaScript application is tricky. It's tricky. So this is what they're doing here. All right, say, hey, I just put it all in one single place, right? But they say, no. Let's go to abstract this into one per handle, right? And they say, okay, so on each effect they are doing one thing. Okay, they are doing one thing. This is on the ideal world, but on the on the day to day, that something doesn't work that way. Okay, that thing doesn't work that way. Makes a lot of sense. So what it's doing here is say, hey, when the now this, right? I don't care about this. Tiki. No, I don't care about this, right? In fact, I don't care even about this, right? Or this. For example, here, I don't need to remove anything. The display. It's interesting, like somehow it is. Okay. Okay, it start with. So if pause is true, pause, otherwise play. But it's playing is false, right? So it's playing is false. Pause that. Exactly. Pause that. But this is quite interesting because here now we create is one specific synchronization, one single thing per synchronization. Okay, instead of doing everything at once, no. Each use effect is being used for one thing and one thing only. Whether it is update the state based on a global event, or or to now update an state, or to interact with an HTML element when a state change here. Holy moly, bro. That is mind-bending stuff. That is mind-bending stuff. Okay. Let's get into this, you know?
So initially, I had planned for this challenge to be an exercise because I thought it would be this straightforward way to practice the ideas we've been talking about. But as I was actually solving this problem, I realized that there's a surprising amount of complexity to it. And actually, it's a great chance for me to share a couple of things I've wanted to talk about. One of them is a neat little trick to make sure that two different things stay in sync, and the other is an escape hatch we can use to access a stale state variable without
two different
changing the
things stayed in sync. All right. Exactly. Two different things stay in sync here. Okay. Come on.
Is a neat little trick to make sure that two different things stay in sync, and the other is an escape hatch we can use to access a stale state variable without changing the dependency array. To explain what's going on here, I've started to solve this.
Wait, what? I don't need to have that displaying exactly. Yep.
Problem using the structure that we've seen a few times now, where I have an effect. It doesn't have any dependencies, which means it only runs on mount, and when it runs, I add this long-running process, right? I subscribe to keydown events with add event listener, and my cleanup function undoes that work, unsubscribing from that event. The callback function checks to see if the key that the user pressed was the spacebar, and if so, I want to either start or stop playing the song. And this is where things get tricky, like how do I start or stop playing the song? Well, we can sort of cheat and look at what we did last time, right? I have this button on click and it does work. It starts playing the song when I click the button. But the tricky thing here is that I'm actually doing two separate things, right? One of them is that I'm changing the state variable. I'm flipping it from true to false or from false to true, but I also have to update the audio tag itself. And essentially, the realization here is that there are two separate pieces of state that I need to manage. One of them is my React state that I change with the setIsPlaying function, and the other is the internal audio state, right? Inside this audio tag, there is some sort of low-level state that controls whether or not I'm currently hearing the song or not. I need to do both of these things whenever I toggle the song's playing state. And so I could copy all of this code and paste it in over here. I don't love doing that idea, right? It doesn't feel very clean to me. I could create a function, maybe toggle playing, put this work in the function, and then call this function in both of those places. That would be better, but it does introduce sort of a weird thing with dependencies that we're going to talk more about when we talk about useMemo and useCallback. And it also doesn't really feel super safe to me, right? This function then becomes the only way to safely change this state, and other developers or myself in the future might not realize that. Like, I can easily imagine coming to this component, not paying a ton of attention, and wanting to implement some other way to start or stop the song, and calling setIsPlaying, and then we'd wind up in this bewildering situation where isPlaying is true, but we don't hear the song, and so like the UI is updating, but we don't hear the sound, and maybe we think there's something wrong
The UI is updated, but we're not hearing
with our
the sound,
speakers.
so, okay.
I really don't want to go down that road. Like, ideally, I want this to be my source of truth, and I don't want to have to think about the audio stuff at all. Well, there is a way we can do that, and we're going to do it by adding another useEffect hook. The idea with this hook is that it's going to be responsible for keeping the internal audio state in sync with this state variable. And so the first thing I'm going to do is I'm going to add a dependency array, and it's going to include the isPlaying state variable so that this effect runs whenever that variable changes with this state variable. And so the first thing I'm going to do is I'm going to add a dependency array, and it's going to include the isPlaying state variable. The first, for keeping the internal audio state in sync with this state variable. And so the first thing I'm going to do is I'm going to add a dependency array, and it's going to include the isPlaying state variable so that this effect runs whenever that variable changes. And I'm going to check if isPlaying, so if we just flip this value to a truthy value, I'm going to call audioref.current.play. Otherwise, if it flipped to a falsy value, I'm going to call audioref.current.pause. This is going to be the one place where I manage this connection, making sure to keep them perfectly in sync. And so when I actually want to trigger that value, right, to start or stop playing, all I have to do is call setIsPlaying with the value I want. The component will re-render. IsPlaying will now be the opposite value that it was, and I will trigger one of these two methods. Now, I should say this is a somewhat controversial approach. There are those who think it's actually better to use a shared function, right? The toggle playing idea I shared earlier. But in my opinion, this is a much more foolproof way to go about it. That way I never have to think about the audio state. I can focus purely on my single source of truth, the isPlaying state variable. With this done, I can now grab the same stateSetter function, and I can call that inside my keydown event listener. Now, when I do this, I get a lint warning about a missing dependency, which makes sense. I'm trying to access the isPlaying state variable, despite not putting it in the dependency array. But just for fun, I think it's a good thought experiment. If I dismiss the warning, what are the problems, if any, that I'll actually have? Like, if I try to use the spacebar shortcut now, will I get an error? Will it kind of work in some ways but not others? Will it work perfectly, and maybe the warning in this case was a red herring? If you'd like, I'd encourage you to take a couple of minutes, pause the video, and think about it, right? Make a prediction about what you think will happen. To figure out if this works or not, I'm going to test it out. So I'll focus this window and press the spacebar key.
So the UI...
And I do hear the song start. So far, so good. I press it again to pause it.
But the UI doesn't update.
Well, it's able to start the song, but it's not able to stop it. To explain what's going on here, I've created yet another graph that shows each of these renders over time. We see in the first render, isPlaying is set to false. We then start our effect, which runs this long-running process. And every time I press the spacebar key, we're calling setIsPlaying to not isPlaying. But the isPlaying state variable that we have is this one, right? We only have access to the data in the same snapshot. And so this effect can only ever read this value. And so every time I hit the spacebar key, I'm calling setIsPlaying with not false, which is true, which explains why the first time I do that, it starts playing the song, which is good, that's what we want. But every subsequent time after that, I'm still calling setIsPlaying with true. I'm not flipping between Boolean values because I only ever have access to this value. Now, if we go back to our code, there is a couple ways for us to fix this. The first one is the one that we've seen before, which is I can add this dependency to the array. With that, we see the red squiggle goes away and things work the way we would expect. But what does this actually do here? Like, why does this work? Well, I have yet another graph to help with that. I know it looks kind of chaotic. Don't worry though, it will make sense momentarily. Things in this one actually work pretty similarly at first. I have my first snapshot is playing is set to false. We run our effect, which starts our event listener. We press the spacebar key. We access the isPlaying variable from this snapshot. We flip it to true. The component re-renders with isPlaying is true. So far, all of this stuff is the same. But then, because we put isPlaying in the dependency array, we rerun the effect. And because the effect reruns, we call the cleanup function, which removes the event listener, like killing this long-running process. When the effect runs, we start a new long-running process, and now this effect has access to the data in this snapshot. And so this isPlaying is now this one right over here. Every time we start an event listener, we have access to the most recent snapshot, and because we're constantly stopping and starting these event listeners, we're able to constantly flip between true and false. And this approach actually works perfectly well. Like, you might look at this and think, it seems kind of wasteful that I'm constantly starting and then stopping these long-running processes. Like in the earlier example, when I didn't have a dependency, we had a single process that was running for the entire component lifecycle, and that does seem like it might be better or more performant. Now, in this case, I should say there is zero risk of this being a performance liability. It doesn't take that long to add or remove an event listener, and it's not like we're triggering the play function hundreds of times a second or anything, like unless you lean on the spacebar key, I suppose. And so there's no performance liability in this case, but there are other cases where the cost of starting and then stopping a subscription are considerable, and in those cases, the React team makes an escape hatch available to us. In fact, we see a suggestion about that in the lint warning. Like if I go back to showing the warning, it says we can also do a functional update calling setIsPlaying with a function. And this is an interesting thing that we haven't talked about yet. So far, whenever we call a state setter function, we pass it the new value, like a Boolean value or a number or an object or whatever it is. But we can also pass a function. And if I pass a function, and let's say I return the number 5, it's equivalent to me calling setIsPlaying with the number 5. Like React will call this function for us, and whatever we return becomes the new state variable. The reason this is useful is that we can set a parameter, and the parameter is the current value of whatever the state variable is. Instead of trying to read the value from the snapshot, which might be stale, I can instead pass React a function, and I can tell React, hey, you tell me what the current value is, and then I'll do something with that value. I'll manipulate it in some way to calculate the next state. If I test this out now, we see that it works just as well as it did before. But notice now, we haven't added anything to our dependency array. And so this add event listener only runs when the component mounts, and the cleanup only runs when the component unmounts. To visualize this on yet another graph, and this is the last one, I swear, it looks actually quite similar to the first one that we saw. I have an effect, it starts a long-running process. Every time I hit the spacebar key, we re-render, and eventually the cleanup function is called when this component unmounts. The difference is that I am no longer trying to read values from the snapshot. Instead, I'm plucking the freshest value possible from the component instance. These snapshots are like moments in time, right? All of the state variables will be defined to whatever value they were in that moment, but these snapshots are generated by using values from the component instance. Like each of these state variables actually lives somewhere inside the component instance, and we're able to access that value by passing a callback function. Now, in terms of which of these approaches is better, which one should you use, honestly, in most cases, they both work equally well. There is a minor performance benefit to doing it this way because I'm not constantly adding and removing event listeners, but in general, these costs are pretty negligible. So in general, I would say go with the approach that makes the most sense to you, that makes your code the most readable. That's usually the more important thing. I would suggest, however, if you do go with this approach, to come up with a unique name for the parameter inside the function. Often tutorials will kind of inherit whatever the name is, so if I'm calling setIsPlaying, I'll make this parameter called isPlaying, and to me that just feels needlessly confusing because now I have these two different variables that share the same name. I like to use current x, where x is whatever the name of the state variable is. I also sometimes will use current value if current x feels a little bit awkward, like current is playing doesn't really read super cleanly, so maybe I'd go current value. Either of those are fine. I just like the disambiguation between what's going on within this callback function and the actual state variable associated with the snapshot.
That's a very interesting thing here.
Is that button tags will automatically fire the click handler if the element is focused and the user presses either the enter key or the spacebar key. And this is a good thing because it means keyboard users, people who don't have a mouse to click on things, can press one of these two keys to trigger the click events. And it's a good thing for us developers because we can use click handlers in a way that is still friendly to keyboard users. In this case, though, it's backfiring because the user focuses the button and hits the spacebar key, which triggers the click handler, but it also fires our keydown listener, right? We're triggering both of these things, which is why it starts playing and then immediately stops playing. To solve this problem, I need to stop one of these two things from happening, and I can do that by adding a new onKeyDown handler straight to the button. I'm going to pass a callback that receives the event, and then I'm going to first check to see if they actually pressed the space key, because all the other keys are fine. Like, there's no issue if they press the enter key. That, works the way we would expect. If they hit the spacebar key, though, I want to cancel out this keydown event listener. And I can do that by specifying event.stopPropagation. Trying this out now, I focus the element, hit the spacebar key, and the song plays normally. To understand what this is and why it works, we have to understand event bubbling. And this is a part of the DOM that essentially makes it possible for us to do things like this. Like, if we think about it, I'm adding the event listener to the window object.
Exactly.
But I don't have the window object focused when I'm pressing the spacebar key. The reason it works is that the window element is the top level element, and when I trigger any event on any DOM node, that event will bubble up the tree. So if I focus the button and press a key, DOM node, that event will bubble up the tree. So if I focus the button and press a key, the keydown event listener will fire on this element, but it'll also try to fire that event on this one, and on this one, and on its parent and grandparent, and all the way up the tree until we eventually reach the window object.
To the tree.
In general, this is a helpful thing, but in this case, I want to short circuit that process, and I can do it with the stop propagation method. Now, this isn't a React thing. This is part of the DOM, part of JavaScript. And essentially, it changes how this event normally works. Instead of bubbling up and up and up, it stops right here, which means the keydown event never makes it to the window object, and so the handler is never called. Essentially then, when I focus the element and press space, it's equivalent to clicking the button. So, it has nothing to do with anything else we've been talking about, but hopefully that's helpful, and if you ever do run into situations like this, now you know how to tackle it.
Holy moly. You ever enter into these situations, which sometimes I will, right? By triggering is the auto. So by triggering is now a set update at the global event, right? And then because okay, and I'm triggering is that, and that event is now bubbling up. That event is bubbling up, bro. Holy fuck. So if I focus here, exactly, it's like trigger that is triggering is the on click, right? It's going all the way up. It's running as this set is playing, so it's flipping from true to false, but also it's running as in this case is this, right? So if I don't do this, and then I somehow now reload this, and then I focus here, it will work as expected, but I lose the ability to actually now update that state here. So what I can say is from here on key down, hey, stop propagating that. So do the update there. Oh my god, it's to cover specific use cases here.
So initially,
It's to cover special use cases here.
So in terms, and all the way up the tree until we eventually reach the window object. Ups right here, which means the keydown event.
Mm-hmm. Holy moly. State setters and callbacks here. In the previous lesson, we learned about a new way to set React state. It is important concept, something we'll be using in the lesson and models ahead, and so I wanted to cover it in more depth. So far in this course, we have updating a state by calling the state setter function with a new value, like this, right? But there is an alternative syntax for state update, which is a state update batch state updates. If we want to pass a callback and React will invoke that function for us, is this. So what essentially is here is saying, hey, React, I do want to call this. Give me the value. Give me that value at the moment that you have, and this is the new value here. Right? In most cases, this isn't necessary since we already have access to the count variable here. But when working with effect, it becomes possible for us to lose access to the freshest version of a state variable. Because at the end of the day, useEffect is keep tracking of, or allows to sync with external source, allows to sync with external systems, and yeah, allow me to sync with external systems. And this synchronization that is going to happen whenever the variables, whenever the dependency array change, okay? Whenever the dependency array change is there. Whenever the dependency array change, bro. Okay, holy moly. So, and any time that that dependency array change, and if we are syncing in that useEffect, so now we are is closing, and so we are stopping and resyncing these things over and over and over and over. Depending on which kind of synchronization we are talking about, and how long that process should be lived, this is when you do this. So in the previous lesson, we saw an example of how to use this alternative syntax like this. This effect only runs after the very first render. Since we have specified an empty dependency array, this means that within the effect is playing will always be equal to false. Each render is a snapshot in time, so we're creating a constant is playing here. I recognize that this is a confusing as heck. No, it's not confusing. It's not confusing. When to use callback syntax? So anytime that you don't want for that particular piece of data, anytime that you need the fresh version of that state. The main use case for this syntax, in my opinion, is to avoid the stale values issue we saw in previous lessons. So stale values are strictly a useEffect things. Anything that needs any particular hook that needs to somehow keep track of reactive dependencies, like use callback, use memo, or any other hook. All right. So we can also run into those sort of issues when using use memo and use callback, discussed later in this model, and also when doing asynchronous work, fetching data, discussed in the next model. Occasionally, it can be more convenient to use the callback syntax. For example, if we are passing the state setter function as a prop to a child component, we can use the callback syntax to modify the current value without also having to pass that value through props. Why not always use a callback syntax? You might be wondering, is there ever a reason not to use a callback syntax? Why not use it in every situation? For example, like this. This is typically a counter app. There are no effect, no asynchronous code, and there is no way for the state to grow stale. But the alternative callback syntax still works just fine. Even though it worked, I don't suggest doing this. At least not for now. But again, anytime that you need a new state, the freshest state of the application, the freshest state of the value, okay. In order to truly become comfortable with React, we need to build an intuition on how effects and renders are connected, and the callback syntax can be a bit of a crunch. If we always use a callback syntax, it will take us a lot longer to build that intuition. Unfortunately, the callback syntax isn't a silver bullet. Even if you use it all the time, you will still occasionally run into situations where the stale values cause issues. And so important that build that intuition so that you can handle the situation as they come up. Here's what I suggest. Use the default non-callback form by default. When you run into bugs, you can try the callback syntax to see if that helps. If it does, spend a few moments seeing if you can understand why. The more practice you get, the quicker it'll start making sense. And then you got more exercise here. Interval counter. I have another good exercise. And then you have the strict mode, which I am quite familiar to do this. And then we look at the custom hook and data fetching and memoization. This is the kind of thing that I need to look deeply into this, because I need to know the tool. Yeah, I need to know about this. Yeah, it is. Oh my god. Yeah, it is. Mm-hmm. 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 That's and this, all of this is the core, man. All of this is the core. So that'll be all for this video. Take care. Bye bye.